Might as well get started. Thanks so much for coming, guys. The reason why I'm giving this presentation, so currently I'm the OIE Junior Ambassador for this university. I'll go more into the position and what I do, but today I'll just talk to you guys about African swine fever. You probably haven't learned much about it yet, but what it is, it's a severe hemorrhagic disease in domestic and wild swine. Luckily it's not zoonotic, so we can't get it, but it causes dramatic decreases in swine production. So you can imagine how much it would affect a certain country like Asia, or continents like Asia, where they rely so much on pork production. So for those that don't know who the OIE is, so they're the World Organization for Animal Health. I won't really go on much about them, but I'll just show you a video and I'll tell a little bit about who they are.
Animal diseases know no borders. In the last century, when a ship on the Cape Route from India docked in Europe, it brought with it not only zebras, but also the river pest virus, which decimated farms in the region. The need for international cooperation to control animal diseases became clear, leading in 1924 to the creation of the OIE, the World Organization for Animal Health. Since then, the OIE has been developing international standards for animal health as a reference for the World Trade Organization to help it safeguard international trade in animals and animal products. OIE international standards help member countries monitor, detect, and control more than 120 diseases affecting terrestrial and aquatic animals and sometimes humans. They also contribute to improving animal welfare and are continually updated to keep pace with scientific developments. Each year, revisions are adopted by the OIE World Assembly of Delegates, where each member country has one vote. Beyond disease prevention and control, these standards also help strengthen animal health systems worldwide. Because only effective and competent national veterinary services can meet the challenges of animal health and welfare whilst protecting people and the environment. Healthy animals provide safe food, contributing to the elimination of hunger. Healthy animals ensure quality of life for farmers and agriculturists, ensuring a vital source of income for both rural and coastal economies. Healthy animals help build a resilient environment in harmony with human activities. By serving as a basis for the national legislation of its member countries, OIE international standards contribute to people's economic prosperity, as well as their social and environmental well-being. And they also contribute to achieving the United Nations Sustainable Development Goals. Because protecting animals means preserving our future.
I'll just go through some of the OIE campaigns that they're offering. So as I said before, I'm part of the OIE Junior Ambassador campaign. So if you're an IBSA member, you can join. A couple of years ago, they developed this program just so the OIE has direct contact with multiple universities around the world. So my job is just to spread awareness about certain health campaigns that are going on, spreading around animal welfare. Like for those that were on the IBSA Facebook page, you must have seen some of my posts. For example, like African swine fever, I made a few posts at the start of the year. Just about antimicrobial resistance, bovine tuberculosis, and also just One Health in general. Just another thing I wanted to point out, the OIE made this really cool app where you could track a lot of epidemic zoonotic diseases around the world. So you actually get push notifications on your phone saying like, oh, there's an ASF outbreak here, foot and mouth, equine infectious anemia in this country. They'll actually give you a report of how they diagnosed it and stuff. It's really cool if you're kind of interested in like disease pathology, public health. But yeah, just for today, I'll focus on African swine fever. So I'll focus on just the current status of African swine fever. Some of the general characteristics of the virus, transmission and replication of the virus, the pathogenesis, how to diagnose it, and how countries go about preventing African swine fever and controlling it to ensure it doesn't spread or enter the country in the first place. So what is African swine fever? Just as I said before, it's a severe viral disease that causes hemorrhagic fever in domestic pigs and wild pigs as well. The reason why it's so problematic, not because it's highly virulent, but because it causes very serious production losses. And you can imagine how that would affect different countries around the world. The way it's spread through live or dead pigs. It could be spread from domestic and wild species, and also pork products as well. But transmission can also occur on fomites and feed. So you can imagine if you're a veterinarian and you're at a piggery that has ASF virus, if it goes on your shoes, on your clothes, even if you're wearing proper PPE, if you go off that property, you could spread it to other piggeries. And the problem is it is very difficult to stop. There's no vaccine, there's no treatment, and it is highly virulent. So if you do spread it, it could go to all those other pigs on that property as well. And as of now, there have been outbreaks in Africa, Europe, South America, and Asia. It does have a potential to spread to Australia, also North America as well. But since you guys have such amazing biosecurity protocols here, it hasn't spread yet, but we have to keep aware of that. Even though it is an exotic disease, there's always that chance it could come in. So just a bit of history about African swine fever. For the longest time, it was always considered a disease of sub-Saharan Africa until 1957, when an outbreak occurred in Portugal. The virus was reported near international airports, but it was thought to spread because people were feeding swine airport waste that was mixed in with the food. And it wasn't until after when the virus actually spread towards Brazil, the Caribbean, and the Mediterranean islands in 1978. And again, this was likely arisen from feeding pigs infected food waste from ships. Afterwards, the virus appeared in Europe in 2007, where it initially appeared in Georgia and then spread towards Russia. The spread was due to feeding local pigs with infected food waste from ships, which have traveled there from southeastern Africa. So I just got this report from the YE website. The date I got it from was between March 29th and April 11th. Just on the map here, you could see the certain operations that were affected. So you have backyard, farm, wild boar operations. Just during that time, there was 1,357 ongoing outbreaks. 124 at the time were new outbreaks. Countries with new and ongoing outbreaks include some countries in Europe, which include Belgium, Hungary, Poland, Romania, and Russia. Asia, which includes Cambodia, China, Mongolia, and Vietnam. And Africa, so South Africa and Zimbabwe, which the virus where it originated. So just to show a bit of proof how scared people are that it will spread, I pulled up a few articles here. So this one here is just posted in a Canadian website called CBC. So just how it says here, so Canadian pork producers say they're watching closely for African swine fever as it spreads through China, wiping out large numbers of the country's pig population and bumping up demand for North American product. So you can imagine how much people are worried about this virus spreading into their country. A couple articles here as well. So African swine fever reported in Siberia, Russia, African swine fever in China. The US, they're also worried about African swine fever as well, just spreading there. Also, yeah, African swine fever. It's not just problematic in this, just in those continents, but it could be a worldwide pandemic if we don't take the proper control measures. And just here, I'll just go on about some of the general characteristics about the African swine fever virus. So it's the sole member of the genus ASF virus. Just those viruses, so they're quite large when you see them under electron microscopy. They are enveloped, and they are DNA viruses. This is how they look like here. So the black arrow there is just pointing at the capsule, and then the white membrane. The white arrow is just pointing at just the membrane there. How does it transmit? So just the way it transmits, one way, it's actually the only known DNA arbovirus. So what an arbovirus is, it's a virus that's transmitted by biological vectors such as ticks. So it's specifically transmitted just by this tick here. It's known as Ornithovirus mubata, which is from the South African region. Some of it's a reservoir host, so like a host where it cycles in, includes warthogs and bush pigs, which are seen in South Africa. The reservoir hosts, they don't show clinical signs because they have developed immunity to it. Hosts that do demonstrate disease include domestic pigs and also the European wild boar. So one way of transmission is by direct transmission. So that's just when sick pigs contact healthy animals and then they'll develop the disease. There's also indirect transmission as well. So that's when pigs feed on waste that includes that infected pork meat. And again, the biological factors, so that tick, the Ornithovirus, and also fomites as well. So you could imagine going on and off a property. It's very easy to carry that disease to one piggery to another. And also within the tick vector, the virus could also multiply through there as well. So transstadial just refers to when the virus goes from one stage of the tick, so for example, the larval stage to adult stages. Then transalvarial, just from one tick to another, just by mating. And then sexual transmission as well. Then one of the cycles, so this cycle occurs in southeastern Africa. This is how the virus actually cycles throughout the reservoir host. So again, just in the reservoir host, you don't actually see clinical signs, but they shed the virus at just such high velocities where it's just so easy to spread. So after the tick feeds on this swine infected with the virus then replicates in the gut of the tick. And then eventually the virus will go up to the salivary gland and then the tick can infect other swine. Then the virus is just also maintained in young warthogs and ticks. Again, they won't show clinical signs, but they could easily spread that virus. Then the next cycle, this is the domestic cycle. So once those reservoir hosts are infected, they could spread it to other domestic swine and also the European wild boar. So this is why pandemics do occur. So pigs infected by ticks that have been transported on live warthogs or their carcasses. The virus is then introduced into domestic swine by bite of infected tick or in feeding on that infected meat. The virus is also excreted through nasal secretions, feces, and urine. And then the virus can also spread via direct contact, so that's when pigs directly contact each other. And direct, so that'd be fomites, so like on your hands, on your clothes, on your vehicle when you're going out of that piggery. And just also aerosol transmission as well. The pathogenesis of the virus. So it mainly replicates in swine monocytes and macrophages and also endothelial cells. And this will result in apoptosis of those cells. So that's why you see that hemorrhagic fever, you see lethargy, vomiting, diarrhea. So it replicates primarily in the cytoplasm, but it does rely on the DNA synthesis from the host to get those virulence factors. It goes into the cell by receptor-mediated endocytosis. And then the virus DNA is transcribed into mRNA by DNA-dependent RNase polymerase. So the way it does cause disease, it inhibits expression of inflammatory cytokines in the cell, so it decreases the immune response of the host. But ASF viruses, they differ in their strain. So some ASF viruses can kill the host right away if it can fully inhibit those inflammatory cytokines. There's actually more chronic forms of the virus as well that the animal could live for a bit longer, but they'll still shed the virus at really high velocities. So the infection, it could be acquired by the respiratory tract. If it is, it'll replicate in the pharyngeal tonsils initially and then the lymph nodes. And then after that, it'll just disseminate throughout the entire body. If it's ingested, it'll just be a severe generalized infection, so just through the blood, and it'll cause a severe viremia. And then swine, if they do live, they remain persistently infected throughout life. Even if they show minor clinical signs, they could be shedding very high titers of the virus. So just how we diagnose this, first thing you do, you look at clinical signs. So the peracute form, so that's like the actual sudden death. So you won't actually see clinical signs because they'll just die. Acute forms, you could actually just see here, just on the pictures on your right, so fever. And then erythema of the skin, so that's just a reddening of the skin, which you could just kind of see on this pig here, just the red patches. Yeah, you can see anorexia. Increased pulse and respiratory rate, and then also vomiting and diarrhea as well. And just chronic forms of the disease, you could see weight loss, respiratory signs, so like dyspnea, chronic skin ulcers, and arthritis. And then, yeah, just another form of diagnosis, so just a post-mortem. So when you actually do your post-mortem on your pig, you see widespread hemorrhage. And then the lymph nodes as well, if you actually look at them on post-mortem, they kind of look like blood clots, so they don't have that distinct like white color. They'll look like red and look like scabs. You also see petechiation of all the serosal surfaces, lymph nodes, epicardium, endocardium, renal cortex, and the bladder. You also see cutaneous ecchymosis, so just the red patches all over the skin, excess pleural, pericardial, and peritoneal fluid, and also splenomegaly, so just an arching of the spleen. One way to diagnose this is just doing a complete blood count, so counting your red blood cells, white blood cells, and your platelets. So when you do that, you'd see leukopenia, so decreased white blood cells, lymphopenia, so decreased lymphocytes, and also thrombocytopenia. So that'd be just decreased platelets. This is just what a postmortem looks like on a pig with African swine fever. So just the top left corner there, you can see those really prominent ecchymoses just on the neck. The one on the top right there, so you could see just ecchymoses on the red patches on the red area. So that's just due to the very severe hemorrhagic fever. See, just those are just hemorrhagic gastrosplenic lymph nodes. So it's just those little black dots there. Like those are lymph nodes. They don't have that really distinct lymph node color and texture. They just look black and hemorrhagic. And the D, for D, that's just an enlarged spleen. So again, that occurs with African swine fever. Just one, if you want to make sure that the virus is actually causing the disease, you could actually isolate the virus. So how you would do this, you just do a culture of the cells using the pig monocytes or bone marrow cells. You could also do a heme absorption test as well. So this is actually like a definitive diagnosis for ASF. So the actual ASF virus, they contain hemagglutinins, which is just a type of antigen, which binds to swine red blood cells. And then you can actually see this when you put that on a sheet. You'll see agglutination. So that's a reaction between the antigen, so the hemagglutinin, and the red blood cell. And that's what they use for a definitive diagnosis. And that's just what it looks like. So just the little dots there, that's the antigen, and that's just us surrounding the red blood cell. And that's just all put on the sheet, and you could see that agglutination pattern. Another way of diagnosing this as well. So just using a fluorescent antibody test. So if you do get a fluorescent antibody test and that pig's showing clinical signs, it can provide a diagnosis for ASF, but the best way is to do that virus isolation and also the agglutination test as well, just to make sure you have it. You could also do PCR as well, so actually detecting the viral genome. So you'd collect samples of the swine blood. You could also take samples along just the viscera as well. Serological tests you could do as well. They're not really that accurate, so that's just measuring antibodies towards the African swine fever virus. If you do get positive antibodies, then you'd kind of go and do your virus isolation test because those are your more expensive ones. Some differential diagnoses for the virus include classical swine fever, hot cholera, porcine reproductive and respiratory syndrome, erysipelas, salmonellosis, Jeschke's disease, so that occurs in young swine, pasteurellosis, and other septicemic conditions. So how do we actually prevent and control this virus? The problem is it is a highly virulent virus, and there's only so many ways you could prevent it. So the biggest thing is there's not actually a vaccine for the virus. So if you know the pig's going to an area that has a high prevalence of African swine fever, there's really not much you could do about it. Just like yeah, ideally you wouldn't want to bring the pigs on those properties. So also you could also get transmission of the virus in fresh and cured pork products. And also as well, usually on swine, sorry, a little bit of water, yeah. And so you also see persistent infection in swine. So like I said before, when you get chronic infection, they can still spread that virus very rapidly, and at high titers as well. And there are several agents out there that cause similar disease as well, just as I listed in the differential diagnoses. And also as well, like I said before, the tick is also involved in spreading the virus. It is a reservoir host. And they're so small and they reproduce at such high volumes as well, so it's very hard to control that tick. So just probably one of the biggest ways of actually controlling the disease is avoid feeding uncooked waste to pigs. You could also prevent the access of ticks in contact with warthogs. So ideally how a lot of piggeries do this, they'll spray a caricide, so like something that kills ticks in the piggeries. Or they could just put as much fencing as possible just around the piggery to make sure they don't come in. Another big thing too is to prohibit importation of live swine or swine products from infected countries. So for example, if you were buying pork product from a country like Vietnam, like I know for sure they have African swine fever, so I'd probably never buy pork from there in the first place. And also you want to make sure you're monitoring the destruction of all waste from ships and aircraft. So you want to make sure it doesn't go in the swine food and infects them. Again, yeah, just to control it, you want to make sure that you recognize it early. So the second you see clinical signs of African swine fever, so severe hemorrhagic disease, ecchymoses around the body, vomiting and diarrhea, it should be reported right away to the YE. And also you want to make sure you have the right diagnostics to ensure that you diagnose it properly. So your virus isolation, antibody testing. Unfortunately, there is no treatment for the disease. So once a pig is actually infected with African swine fever, it has to be euthanized right away. And any other pigs that are in contact with it should also be euthanized. We also have to make sure to properly dispose of those carcasses so no other pigs actually come in contact with it. And then, yeah, last but not least, sorry, we have to respect proper biosecurity measures. So whenever we do go on a pig property, You always just want to make sure that you're wearing the proper PPE and you never take it outside the piggery. Make sure it doesn't get on your vehicle. Make sure you're always wearing proper PPE and then wearing different clothes outside the property as well. I think yeah, that's about it. Do you guys have any questions? No.
How close are they to developing a vaccine?
There has been a lot of research into it. I don't think anytime soon, but hopefully by the time you come back, it'll be implemented. Yeah. Yeah, that's all good. Yeah, I hope so, yeah.
But even those that do never get rid of the virus. So think about how vaccine works with most vaccinations that we have. You know, like most of those diseases we try to eradicate. So because there's also that, because it's such a big virus. So I don't know how possible it would be. They might just get it done at some point in time, especially if you can't sleep through response. Exactly. It's just cuddle and eradicate.
Yeah, any other questions? It is pretty serious. Usually with the virus, you start seeing clinical signs right away. So even if, usually it's kind of shed in really high titers. So pigs can easily pick it up, and usually they show acute signs right away. A lot of them tend to actually die from the virus. Very few of them actually end up becoming chronic cases, and then will just persistently just shed that virus. And then, yeah, most likely it's usually acute cases and sudden death. Yeah, millions, yeah. Yeah, definitely. That's kind of surprising how many people don't know about this. I think like just like in Asia, it's such a huge problem. Like when I went to Vietnam, like all the piggeries I went to, they had it. But African swine fever. Yeah. Yeah. Like the good thing is like it doesn't affect humans, but it just causes such serious production losses. But again, like if you're eating pig from a third world country, it's like probably has some other stuff as well. Yeah. Yeah, exactly. All right, thanks so much, guys.